So we're going to take the equation that we got before for average acceleration. We're going to apply it to a real problem. So let's say you're driving around in your Porsche Carrera. Well, you hop in your car while it's in the parking lot. You pull out the lot, and as soon as you hit the highway, you accelerate from 0 to 0 miles per hour, 60 miles per hour. But turns out you're not that fast. It takes you a half hour. So how do we find the average acceleration? So 1/2 hour is just the same as 0.5 hours. So looking at our equation, average acceleration is going to be equal to change in velocity over change in time, or final velocity minus initial velocity over final time minus initial time. So our final velocity was 60. Initial velocity, so we take minus initial velocity of 0 divided by change in time, 0.5 hours. So it just becomes 60 over 0.5, which just equals 120 miles per hour squared. So for those of you who are wondering why it's miles per hour squared, I'll demonstrate that. So we had 60 miles, I'm going to write it like a fraction, per hour, divided by 0.5 hours. So dividing by 0.5 hours, turns out you can rewrite that. It's the same thing as writing 60 miles over hours times 1 over 0.5 hours. Now that it's in this form, you can see that you end up with 60 miles divided by 0.5 hours squared. This is hours times hours. 60 divided by 0.5 is 120. So it's 120 miles per hour squared. Now in most of these problems, you're going to see meters per second, or you're going to see SI units. So if there's an acceleration problem with SI units, it's going to be in meters per second squared, for the same reason that we wrote miles per hour squared in this problem. Let's look at another problem. So let's say one of the UT 40 acres buses is going 10 meters a second, and it starts hitting the brakes, it slows down, decelerating at an average and uniform acceleration -2 meters per second squared. How long does it take to stop? Well, my first step is to look at the equation again for average acceleration. Average acceleration equals final velocity minus initial velocity over time interval. In this case, we have the acceleration right here. It's -2 meters per second squared. We have the velocity, Well, we have the final velocity, the initial velocity, 10 meters per second. So I'm going to start writing these variables down. A average equals -2 meters per second squared. I said we have the initial velocity equals 10 meters per second. We actually also have the final velocity, because I said this bus is slowing down to a stop. So the final velocity must be 0. What are we missing? We're missing delta t. So let me just rewrite this so that I can have delta t as what we're going to find. So I'm going to rewrite this equation. Here's the equation we use. I want delta t on one side. So here we have this part divided by delta t. The inverse operation would be multiplying by delta t. Both sides of the equation multiplied by delta t. Now the delta t on this side crosses out. So I have delta t times average acceleration equals final velocity minus initial velocity. So we still have delta t times acceleration. I want just delta t. So the inverse operation of times acceleration is dividing by acceleration. I'll divide by acceleration. Of course, I'll divide this side by acceleration. Here it crosses out. So delta t equals final velocity minus initial velocity over acceleration. Now we're in business. So let's look over here. Plug in numbers. Delta t equals, let's see, we're looking for a final velocity. We said that's 0 meters per second minus initial velocity, we said was 10 meters a second. We divided by acceleration, which we said was -2 meters per second squared. So the top expression, 0 minus 10, is just -10. So we have -10 divided by -2. So change in time, it's just positive 5 meters. Sorry, not 5 meters. 5 seconds. So change in time was 5 seconds. So looking back at our equation, as long as you have acceleration equals change in velocity over change in time. So 3 different quantities we're looking at. Anytime you have 2 of them, you can always find the third one easily, like we did in this problem. So that's all we're going to do for acceleration right now.